Application problem, bearing. So we've got a ship here at 0, 0. The problem says it travels 6 miles along a bearing, in other words, a heading or a direction of 20 degrees below the horizontal. You can almost think of this like angle of depression. We're using the horizontal as our starting point. We're going 20 degrees below that. So here's the horizontal. 20 degrees below that would be somewhere along this direction. Then the ship turns and travels 8 miles along a new bearing, a bearing of 50 degrees above the horizontal. That's kind of like angle of elevation. Now, to make my picture, I'll have to draw in an imaginary horizontal here, and then from this spot, the ship starts heading 50 degrees above that horizontal. And it does that for 8 miles. Our question is, what are the coordinates of this final point? Well, I'm going to have to do this problem in 2 pieces. The first thing I should figure out is the coordinates of this point right here. And I can do that by dropping or raising, in this case, a perpendicular, forming a little right triangle. If I can just figure out the length of this side of the triangle and the length of this side of the triangle, I should be able to fill in the coordinates of that point. Well, this is where trigonometry helps me. I've got a right triangle, I've got one angle inside it, the 20 degrees, and I've got the 6 as the hypotenuse. How about I label these A and B? To find A and B, I can set up a couple of trig equations. Let's see, the cosine function would link up the 20 degrees with the adjacent side and the hypotenuse. The sine function would link the 20 with the opposite side and the hypotenuse. So I have cosine 20 degrees equals A over 6, and sine 20 degrees equals B over 6. We could multiply everybody by 6, and then I have expressions for A and B. A equals 6 cosine 20 degrees, and B equals 6 times sine 20 degrees. I can get those values off the calculator. We need to be in degree mode here, so let's fix that. So I'm in degree mode now. Looks like 6 cosine 20 degrees is 5.6382 or so, and 6 sine 20, 2.0521. I'm keeping the decimals a little long because I'm going to use these values later in the problem and I don't want to have any rounding issues. Now be careful, obviously the A distance is positive because it goes to the right, but the B coordinate is negative because it goes down. The calculator had no way of knowing that. The calculator thinks I'm sticking in a first quadrant angle, but I'm in the fourth quadrant here, so I need to make sure I attach a negative sign to the B. Okay, here's what we'll do next. If I drop a perpendicular from that ending point down to that horizontal that I drew in, that gives me yet another right triangle. Once again, I know one of the sides. I know the hypotenuse is 8. I know this one angle here is 50 degrees. I should be able to use trig in the way we just did to find both this distance and this distance. And if I have those distances, I can then adjust my previous coordinates to figure out this final ending spot here. Okay, why don't we call this side C and this side D? And let's figure out those values. The math is going to be almost the same as what we already did. I have cosine 50 degrees equals adjacent over hypotenuse, C over 8. I have sine 50 degrees equals D, opposite over hypotenuse, D over 8. Once again, we'll clear the fractions. And we have C equals 8 cosine 50 degrees and D equals 8 times sine 50 degrees. Let's again get those decimal values. 8 cosine 50, 5.1423. 8 sine 50, 6.1284. All I have to do is add these distances onto my previous coordinates, and I'll know my final ending spot. This point here, I had traveled 5.6382 to the right, and then to get here, I would have to go to the right another 5.1423. When I add that and round to one decimal place, I get about 10.8. For the y coordinate, I went down to negative 2.0521 and then from there went up by 6.1284. Up is positive, so if I add 6.1284 here, I'll have the y coordinate. and that comes out to be about 4.1. So the final answer, the final coordinates come out to be about 10.8 comma 4.1. It looks pretty reasonable from the picture. That would mean traveling from 0, 0 over about 10.8 and then up a smaller distance, about 4.1. That's where the ship ended up. Thanks for watching.